Let's start. Let's start, madam. Ganesh is here already.
Uh,
Am I audible,
so,
Ganesh?
Hi, yes, I can hear you. Can you hear me?
Yeah. I can
Great.
hear you.
Thank you.
Fine.
Thank you.
Yeah. Mhm. Should we wait for a few more minutes? Maybe 2 more minutes.
Hi, yes, I think last time there were
Mm.
more people.
Yeah,
Currently,
yeah.
it's at 18, including us. So, yeah,
Mm.
let's give them a few more minutes.
Yeah, that would be better. Yeah. Audible, Ganesh? Hello.
Hi, yes, I can hear you. Yeah.
Okay. So anyway, let's start. Yeah, maybe we'll look at the questions. we received in the forum first. Okay. So the first question is by Tanmay Prateep. Okay, the entire question was not visible. We'll see. Practice assignment. I did not understand the fourth question. On an 8-bay chessboard, place two knights such that the two knights are adjacent, meaning their squares share a horizontal or a vertical side.
And at least one knight is placed on a corner square of the board. The question is, what is the maximum number of squares the two knights can attack if they are placed under these conditions?
Okay. Okay, so this one and two together should be satisfied. That's what you meant,
Exactly.
right? Okay. But then question, what is the maximum number of squares that two knights can attack? So then they just you place this way and directly calculate it, right?
Yeah. I like we can't say like what exactly they don't understand about the question. So maybe like they can mail us exactly
Yeah.
like where they are stuck. That would be
Tanmay
better.
Pradeep possibly is in the Zoom call. Maybe he may explain the question better.
Yeah. It seems only the representatives are here in the Zoom call. Everybody else is in the YouTube
YouTube.
link.
Okay.
Yeah. So only the representatives from each school are here.
Okay. So this question, what is the maximum number of square that two knights can attack? Like that's a question we gave it to them. So he has just to share it. Maybe he wants he wants us to discuss this question briefly. Maybe just to say one or two lines about this. Or
Yes.
I think I don't know. Like the question is pretty much straightforward, right? Just you place the knight on our this board and liches, and we can directly count the number of squares these two knights attacking, right?
Mm-hmm.
Or
Yeah.
you want to share the screen and maybe you want to explain it?
Just 1 second. Maybe I'll get this ready and we can just
Okay.
go to next question. Yeah.
Okay. So maybe these types of question, like with the practicality, are some issues. Like I'm not receiving the Zoom link for the weekly discussion session. I only received the YouTube link. So these questions were taken care of already, or we should discuss that. What is the this, thing, like Bhavani ma'am or anybody from NPTEL team?
Yes, sir.
Ma'am, like some student is saying like I'm not receiving the Zoom link for this weekly discussion session. So such questions in
Yeah,
this list you have.
you can ask them to write an email, sir. We have forwarded email and WhatsApp to all students regularly. From
Okay.
Friday onwards, we have sending that. Some more
Okay.
students may be missing that. You can skip those admin-related questions. You can ask
Okay.
them to write an email. That is enough.
Okay.
Or else you
That
can
would be
skip
great.
those admin-related questions.
You will take care of
Yes.
them later. Okay.
Yeah.
Thank you, madam.
Okay.
Okay, that is good. So, in short, like if you have some issues, please write to this our school connect team. They will get back to you as soon as possible. Okay. How many possible combinations are there for placing maximum number of non-attacking queens on an 8-by-8 chessboard? Is it 8 or more than that? The answer is more than that. There are more than 8 configurations are possible.
There are like
So
92.
yeah, yeah. So the number is much larger. So one thing what you need to do is you have. I mean, this course is not just about like you just place these 8 queens in all possible ways. Some of them will be not non-attacking. Some of them, some configuration may not be non-attacking. So don't go by brute force. Just a trial and error. You place one configuration of 8 non-attacking queens, and then you try to find one more. So then you try to understand the pattern. So once you get the pattern, in each pattern, you try to generate all possible combinations. That is like there are only through by understanding the pattern only actually you can get all these 92, I think. Yeah, 92 number of configurations. But so far, if you have got 8, it is still good. Remodio. But I would suggest please try a little bit more. Maybe out of this 8, you try to understand the pattern. The pattern will tell you how to modify this existing 8 configuration to generate more and more configurations. Yeah, that's one way of doing it. You have something to add, Ganesh?
No.
Okay. So, and again, maybe next question. Open and closed nights to teach again, sir. This question is bit not clear to us, Kishore Bala, because like always you can look at the video for the second time, right? And so what you are asking is not clear. You want more examples. I think the definition, we have given some example of a open night store, closed night store. We have actually constructed them explicitly. So you want more, or you have some particular doubts on these topics? It is not clear. Probably if Kishore Bala, MS from DAV BHCL school, please, maybe in the next week, you please write your question more clearly. We can get back to that. Okay. I think Ganesh, they can watch that video any number of times, right? They can go back and watch the video again and again.
I
right?
think. Anyway, it's on YouTube also. So.
Yeah, true. Okay, how to calculate the probability for dices and the degree in an maybe in an 8x8 board. Maybe calculating degrees, again, we give good number of examples in the video. So degree of a square, like there are 2 scenarios can happen. Suppose you look at the empty board, then you place a knight, then you just count all possible square where it can move to in a single move. You count that, that is what we defined as a degree. But now it's an empty board. But now in the second scenario, already there may be some pieces are there, or some squares you have already visited. So when you calculate the degree, we don't want to count the squares what you have already visited. So we have to count the squares where you can move in the next step, provided those squares are yet to be visited, right? So then you just count those squares. That would be degree. And regarding calculate the probability for dices. So I don't know, like you 1 or 2 dices, 3 dices in different cases, calculating probability, at least the value will be final answer will be different. And probability of what we want to count is also matter, right? So let's consider maybe 2 dices, okay, 2 6-sided dices, and we can. So then, what is the all possible outcomes? So it is like from 1 1 1 1 2 1 3. It can go up to 1,6, then 2,1 2,2 2,3 2,6 up to then 6,1 6,2. It can go up to 6,6. So so this accounts are all possible events. Then what probability of what you want to calculate? Suppose I want to calculate the probability of getting the same value in both die. Okay. Both dices. Then what is my favorable outcome? Okay, 1,1, 2,2. So there are 6 of them. All possible, the total number of possible outcomes is 36. 1,1 to 6,6. So 6 by 36, that's how we define the probability. Number of favorable outcomes by number of possible outcomes. So it is 6 by 36, we'll get 1/6. Yeah, so by generalizing this, you can calculate the probability by using this formula, number of favorable outcomes by number of possible outcomes. Again, we can Saksam Agarwal. Please refine this question and you ask more, maybe more detailed version of this question. We can get back to this question next week also. That would be better, I think.
Yeah. So
Yeah.
just one thing, maybe it's a bit better if you turn on the video.
Me?
Yes.
Okay.
Yeah, and somebody wants to ask a question here. Yegala Ranjit. Yes, Yegala Ranjit. You can just unmute yourself and ask the question.
You raise your hand, is it?
Yes. Yegala Ranjit and Ashwant. Ashwant SD. Just unmute and ask the question. It's okay.
Sir, like on the first video of the second week, there was like you have explained the number of squares and the theories with S and T, right? I have a there's a doubt on the thing. Can I share this screen?
Yeah, of course.
Yeah, so I don't understand the question. There was some disturbance in the voice.
He's about to ask the question. Yeah, please ask.
Okay, please go ahead.
The screen sharing is disabled, so can you enable it?
Oh, screen sharing is disabled.
Yeah.
What is the from?
Just a second.
I think we cannot do that because the more option there is chat, ask to start video, and allow to
Yeah, Ashwant, can you check now? Can you check if you can share?
Oh yeah, yes, sir. Yeah, I can share it now.
Yeah.
Okay, good.
So on this on this part, you've explained that after S, T should come. But after here in T, when it went here, it's still T. Is my understanding wrong, or there should be S instead of T?
I think there are multi. I think it's two times I wrote this ST, I think. So, but I think it should be yes only. Yeah. So
Okay,
anyway, it
sir.
should come. I mean, end of the day, we know it should be ST only, right? Maybe I might have wrote T there and try to say it was leading to some problem. If two T's follow, something like that.
No, sir. You try to explain why it's 32 here and why that we have 32S and 32T, but after S when it was T here, then yeah, after that you wrote T here. That's why I thought my understanding was wrong and asked you.
No. I think so. Anyway, 32 is the maximum. We give a different argument. Here we try to prove that the maximum is 32 and all the squares they are of same color. That's what for that only we are using this closed night store idea. Then if we are starting at this square, it starts at yes, then it is T, then it should be yes. Yeah, maybe it was a mistake from my side only. It should be yes. Then again, this should be T. This should be yes. This should be T. Yeah, everything should be consecutively changed to ST. Yeah, correct.
Okay, so thank you, sir.
Sure. Yeah. Who is the other student, Ganesh? Somebody else has raised their hands. Obviously.
Yes,
good evening, sir.
Yes, good evening, please. Please tell your question.
In practice assignment, I had a doubt that in one question they have given that count the number of squares in 8 into 8 chessboard in fifth degree, I couldn't understand that question.
Uh, Basically, you have to count the number of squares. Okay, you take the empty board, chessboard, 8 by 8 board, and you see how many squares are there of degree 5. That's the question. Does it make sense now?
Yeah, fine, sir.
Yeah, so if you take the empty chessboard 8 by 8, every square we can calculate its degree. So basically on a chessboard, you can explicitly write its degree on each of the squares. Now see how many squares are there of degree 5. So it's a straightforward problem only. Yeah. But maybe after you calculate, after you figure out the first square of degree 5 by using again some symmetry or some patterns, you can actually without finding all the squares, you can directly guess the number of squares of degree 5. If you could do that way without actually explicitly calculating the degrees of all the squares in the chessboard, that would be little better. Maybe you give it a try that way.
Yeah, sure, sir. Thank you.
Sure, welcome. Yeah.
Egala Ranjit, if you're here, you can just ask your question. Oh, okay. I don't know. Maybe we're not here. Okay, so there are more questions in the chat. Will the next game or topic you are covering have a specific law which would allow us to solve the puzzles?
Next one is Pexalator, right?
Yes, it is. It is.
I mean, there is no specific law, right? But broadly, whatever, we don't want to say use a specific law. That is the first thing, because then it will be more, we don't want some specialized tools from some branch of mathematics per se. We want to keep it in the elementary level. So for that, what we do, we use this broadly. We want to give simple logical reasoning that will convince us that whatever we are doing is logically correct. There is no gap in our argument. So when we say 32 is the maximum number of knights that one can place on an 8 by 8 chessboard, non-attacking knights on an 8 by 8 chessboard, now we have a logical argument using this knights too. So now we know for sure our answer is correct. So earlier we tried trial and error method. So we could come up with 32 knights, non-attacking knights. But always there was a question in our mind that how do we know that 33 is not possible? But then by using knights too, we proved that by using some simple logical reasoning, we proved that 32 is the maximum. Okay. So all our topics will be along this line only. So if you look at this 32 non-attacking knights problem, specifically we haven't used anything except we deduced a logical argument through which we can clearly see 32 is the maximum. So in the subsequent topic, say Pexalator game, some versions of the Pexalator game, you can solve that game. Some version you cannot solve it. Okay. But how to prove some games has no solution. Okay. There is a game, there is an objective. You have to reach that objective. But the game can be played in million different ways. But I claim that you try any one of these million possible ways, it will not reach the objective. You can't reach the goal. So we don't want to we want to check all these 1 million possibilities. Whereas through logical reasoning, will give a argument without any gaps that you can tell to anyone. They will answer convinced that yes, correct. Now I am convinced this game has no solution. So mostly we go by this logical reasoning uh, type of solution only. Yeah, no specific tools or anything is needed. Ganesh, you have something to add? Maybe you have a different understanding of this question.
No, I don't have anything to add. Yeah.
Okay.
Yeah. Okay, so next one. When you told us to prove the Knight's Tour on 3x8 board, should we prove it by using the math resources Knight's Tour, or is there another way? So I think you're asking, are the resources that you have from the videos enough, or do you need more? That is how I understand it. You might need more, but you might not need a lot of new things, but still you need a bit more, which might even be outside the scope of this course. But so the methods, the way to think about 3x8 is based on what we have in the video, but it's not just that, right? So can you explain 4x board Knight's Tour?
But that is already given in the video.
In the video, yeah. So R Divya, you are in the meeting, I think. So what exactly about 4x should be explained more? Because it is in the video. So if you can tell us what exactly we should explain a bit more, maybe explain better, that'll help us. Okay, the next one is when you said if the number of squares is odd, like 3x7 or 3x9, it's not possible to get a Knight's Tour, closed Knight's Tour. Is it possible to get a Knight's Tour on 25x25 chessboard? No. I mean, if the number of squares is odd, you can't. 25x25 will be an odd number. If my arithmetic is not too much off. Yeah, the same logic. If you take any chessboard with an odd number of squares, then you won't get a closed Knight's Tour. Okay. Right. So that's all the questions in the chat. Let me go back to the form, the doubts in the form.
Okay, let's get back to the form. Okay, sir, can you please explain the knight's move in 10x12, 8x9, and 3x board chessboard? This is by Dia P. Sankar. So knight's move remains the same in any board, irrespective of the dimension. So 10 by 12, 8 by 9, 3 by 4, I think, the knight's moves are the same. It is, maybe you want to ask something more. Maybe you want to ask about knight's tour or something on 10 by 12, 8 by 9, 3 by 4 chessboard. Can you please explain the knight's move in 10x12, 8x9, and the 3 by 4 chessboard? So knight's move remains the same in any board, any M cross N board. Only that much they're asking, no, Ganesh?
I think.
We are not changing the way knights move if we move to different board than 8x8 board. So everywhere, knight's move remains the same. Yeah. This is course like a basic introduction to algorithms and statistical mathematics. No. Strictly no. Maximum number of non-attacking bishops, is it 14? Correct. 14 is the right answer. So now others who were attending this session, please try to get this number 14. This is one very interesting problem, this non-attacking bishops problem. The answer is 14. Try to find one such a configuration. Once you get a configuration, then you can see some symmetry there or patterns there, using which actually you can generate all possible such a configuration. Okay, so getting one is difficult. Once you get, you can list all possible such configurations. So please keep trying this problem. Number of non-attacking, maximum number of non-attacking bishops. Now we are last week, I think we were not giving you the answer. I think I asked you to try for some more time. So the answer is 14. This is correct. Yeah. How
Yes.
to write?
Yeah, so there are more questions in the chat. I mean, since the students asking questions in the chat are here, so it might be
Yeah.
better to just go through them
True,
first.
true. Yeah.
Is there a knight's tour on 4x6? Can we calculate how many moves is required for a knight's tour in 4x6 without using the board? So 4x n includes 4x6, right? There you take n to be 6. So it is included. So how many squares are there on 8x8 chessboard whose degree is 5? So they are asking, what are we supposed to? Oh, I think that question has been deleted. Maybe they've realized what to do. And Ritika Kumawat, please unmute and yeah, you can ask your question. They are raising their hand. So when I'm using one-star flaw while trying to get a knight's tour, when the degrees are same, do I go for the square near the corners?
Maybe that is better. Yeah, but deciding among two squares of same degree, you can go for either of them. At least rule is not specifically saying anything about these two squares. It just says that you can go to any one of them. But again, as you said, like out of our common sense, we know that we want to fill the corners and the boundaries first. Then we want to move into the move towards to the center, because center usually tend to the squares on the center tend to have better degree, so they can be revisited later. No harm in postponing them for postponing them for the future. That is there. So keeping this in mind, I would say after two squares of same degree, better we go for one is near to the or closer to the corner. That will definitely improve the quality of the. I mean, that will definitely improve the success rate of getting the knights too. True.
Yeah. So about the number of squares with degree 5, they are asking what they are supposed to do and how is the answer 0. So as to what you are supposed to do, you start with the empty chessboard, take a square, put a knight on that square, and look at how many possible moves you can make, and you look at how many possible distinct squares you get where this knight can go. You can do this for each square, right? That is pretty straightforward. And you will realize that if you do this for enough number of squares, you don't have to do for all the 64 squares. By symmetry, you don't have to do for all the 64 squares. And if you do this for enough number of squares, you will realize that there is no square with degree 5. It's pretty straightforward. Just look at the knight's move. That's all. If a knight's tour is possible on an m cross n board, is it always possible to make it a closed tour? Okay, so they are asking if there's an open tour, is there also a closed tour?
I remember in some cases, no, right? I mean, if you look at the list of values of m cross n, where there is a open tour, there is a closed tour. These are like different lists. That alone means that there are values of m cross n for which there is only uh, open tools, right? Maybe explicitly.
Like 4 cross 4, there is an open tour in 4 cross 4. But we proved it in the video that there is no closed tour. So for a particular example, you can take that.
Yeah. So maybe
Right.
you can emphasize
So is
that
there
to
a
say something is wrong enough to give an example.
yes.
So to say a statement is wrong, you have to give one counter example. So if you have a open to on an M by N chessboard, then is it always possible to construct a closed tool on that M by N chessboard? That is a question. The answer is no. So to say some statement is wrong, what I will do, I'll give an example where the statement fails. So you look at this 4 cross 4, is it?
Yes.
What was your
Yes.
counter example?
4 cross 4.
4 cross 4, there's an open tool. In general, even in 4 cross n, for any n, we cannot have a closed tool. So that is a counter example. Yeah.
So is there a quick way to know if a knight tour is possible on M by N board without actually constructing the tour? So if you look at the videos now, that is basically what we've been doing. So we've been trying to find M and N, the cases of M and N, where we can find the knight tour, or we can prove there is no knight tour, right? So if we do this for basically all the cases, we'll have a characterization of the pairs of numbers M by N where there will be a knight tour and where there will be no knight tour, right? And this is already known. I don't know if we mentioned this in class. We know exactly for what M and N there will be a knight tour, closed knight tour, and there will be an open knight tour. So we already have this characterization. So yeah, but this characterization came from working with it, playing with the board, and proving for all these cases.
Also in the maybe in the coming week 3 videos, we will see graphs where this knight tour problem, it will be rephrased in the words related to graphs. So maybe using through graphs, it is probably easy to visualize the existence of knight tour, right? Maybe for example, like you fix a m cross n board, then you ask the question like whether there is a knight tour is possible on this m cross n board. So immediately there is a graph called knight's graph. And in that graph, we will be looking for a open Hamiltonian path or Hamiltonian cycle. All this notion we will see in the upcoming videos. And using some, again, some ideas coming from graph theory, we can check whether in a given graph there is a Hamiltonian cycle is there or not, or Hamiltonian path is there or not, that we can do. So after maybe end of third week, you will get you will get to know more tools using which you can decide the existence of the knight suit. That's yeah, that would be basically more clear, I suppose. Yeah.
Right. So when we are checking the degrees and one of them ends our game, are we allowed to backtrack and go for other shortest degree? I think you've maybe misunderstood what to do here. So when you are checking the degrees, right, there is no game. You start with an empty board, pick a square. On that square, you put a knight, and you look for the possible squares that this knight can move to. That's all. There is no game there, right? Right. Okay, so he's saying I meant while we made progress.
When we try to
I'm not sure.
construct a knight's tour, maybe at the at the particular step.
So Veerabahu Shankara Narayanan, can you unmute? Maybe that'll be better. Like, what do you mean when you've made progress when checking the degrees?
Oh, maybe he meant so you're going to a square.
Oh, okay. So Okay,
From
he's
that
trying to
square.
construct night. Yeah.
Yeah.
He's not
Mm.
talking about the previous question.
No,
Okay,
no,
he's trying to
no.
construct to do right. Okay. Yeah.
So,
So
yeah, please go ahead. Yeah.
when they are checking the degrees, okay, he's constructing a tour. He's at a square. He's looking at the onward degrees of each of these squares, and one of them ends our game. Are we allowed to backtrack and go for the other shortest degree?
Why do we need
Yeah.
to backtrack?
I mean,
We are not
it
allowed to
ends
backtrack.
there. No, in the sense, I think they mean ending the game, as in it doesn't give you the tour, but it is just stuck.
Yeah, it's stuck means so basically we haven't probably. I mean, if you use one stop rule, chances of that happening is uh, almost impossible, right?
No, I mean, if they get stuck, they can backtrack, right? That's all they are asking.
But the entire idea of one stop is to construct night store without doing backtrack. No, I mean, if you are allowing backtrack, then you don't need a one stop. You can do any number of
No. In the
backtracking.
sense, no. In the sense, let's say there was a tie at some point in the game, and they picked, let's say, square A, and they continued, and somehow they are stuck. Now they can come back and choose the square B and go. No.
So in the previous step, there are two squares, right? Like squares A was there and square B was there. Square A and B were there. So you calculate the degrees of A and B. And by one stop, you will choose the one with the least degree. So what if
there's a tie?
If there is a tie, both have okay. When there is a tie, okay. But can such scenario occur?
Yeah, it might happen. At that point, the best thing to do is to come back to that point and just
True. I mean, maybe that is the only
continue the
scenario we
other
can
route.
allow backtracking. Yeah. In general, we don't want to allow backtracking. Without allowing backtracking, constructing the night store is the main goal of this one stop window. Yeah.
Right. Okay. And let's go back to. So there are some more questions in the chat which have either already been answered or just repetitions. So I'll just go to the questions in the form.
How to write assignments? What is that? I mean, maybe team will answer that. Please write to the School Connect team. We move on to the next question. On a 5x5 board, the night starts at 3,3. Okay. Which of the following destination squares have exactly 3 onward night moves? So this is from practice assignment, is it? You remember this, Ganesh?
I don't know if it is from practice or graded. I don't have the portal on now.
Okay.
But it is pretty straightforward.
Yes. Yeah.
Yeah.
Which of the following destination squares have exactly 3 on? So I think there are we have given options. So which of the following destination square? So each of them we can directly calculate
find the number of odd one moves.
Yes. So this should be doable. Charlie Rose, please try one more time. You will get the answer easily. Why assignment didn't come to me? So I don't know. Sir, how to do assignment, where to do it, and where to submit it, where is modules, where in handbook. So maybe NPTEL team, please guide students. Still students are not sure like how to maybe submit assignments and other things. Deva Prasad, I request you to please drop an email to our team. They will reply back to you. I will also tell the team to share a common instruction on how to submit the assignments. If a question asks to find the probability of either a red card or a multiple of 3 being drawn, does this include the probability of drawing both the red and a multiple of 3 card, or just a red card or multiple of 3?
Good question.
But usually that meant and, right?
That is
how the
union.
question was, how the question was phrased? Find the probability of, there is a either here, right? Find the probability of either a red card or a multiple of 3 being drawn. Right. Okay. So how to convince Aditya that we are talking about union? So usually, like if you remember set union, A union B, that means that if you take a element A belongs to capital A union capital B, that element can either coming from A or coming from B. So usually this either or corresponds to union, and corresponds to intersection, right? So, and if you ask me, does this include the probability of drawing both red and a multiple of 3 card? I mean, intersection is a subset of union. A intersection B, subset of A union B. So these events also belongs to the list of favorable outcomes. Yes. Okay. So the answer is yes, but these alone will not entirely constitute our favorable outcome. There will be more. In one card, you take it to be red. Both a red card and a multiple of 3, right? So what was this experiment, Ganesh?
Which
You
one?
have a deck
Sorry.
of you have a deck of card and rolling a dice, is it?
I think I didn't write this question, so maybe. Yeah, it seems just from a deck of cards. Yeah.
Then why
But still,
red
anyway.
card?
Yeah, I would have to check the question in the portal.
I think, I mean, diamond and hearts, right?
Is this from the videos or is this from assignment?
Maybe Aditya is there in the call. Okay. In general, either means union, and that favorable outcomes include this case also. Probability of drawing or the outcome in which both a red and a multiple of 3 occurs. That outcomes also will be part of our list of favorable outcomes. I think that alone.
Yeah, it is part of the graded assignment.
Okay. So maybe I have given you some hints. You can think about it. Or just a red card or a multiple of 3. Yeah, anyway, now I have said union, so I have answered pretty much. I have given almost a full answer to this question. You can complete the solution. Can I get the notes of the class? I think so. They will share it. If you write to the team, they will give you. How I supposed to log in with SC? I have not received a password to log in. Please write to the team, full connect team. They will get back to you as soon as possible. And so team said they will look at this general admin related questions. They will get back to you. Okay. What are the maximum number of non-attacking queens which can be placed on a 8-way chessboard, and how are they arranged? Also, if the non-attacking knights have to be placed on a square of both colors, is the maximum number of knights 24. So, first question, what is the maximum number of non-attacking queens which can be placed on a 8-way chessboard, and how are they arranged? So please try a little bit. Okay. So the answer is actually in the last week discussion, we briefly discussed this problem. Maybe you try to place 8 and you try to guess the maximum number. And regarding non-attacking knights in which both colored squares are used, the answer is not 24. It is a number larger than 24. Yeah, please try for some more time. Next week we can discuss. So if you don't have this extra constraint, the answer is 32. I can tell you if you put this extra constraint that you have to use both color squares, this answer is very close to 32. Okay, so I'll say 31 or 30. You try to find which one it is. Okay. Okay, next question. A knight starts at square 1, 1 on a 6x6 chessboard and follow one star rule to choose its next move. Which of the following could the knight land on after making exactly 3 moves?
Yeah,
None
so
of
there are
them.
some options, and then they are continuing. So here, do we consider that the knight can move back to the place it comes from, or does it try to complete the knight's tour without going to the square it had come from?
We always assume that no squares are allowed to be repeated, right?
Except the first one.
Yeah, to for the purpose of completing the two. So I think that answers this question. I did not understand the proof for not getting the knight's tour in 3x6 board explained in the video.
Okay, so I did the proof. So unless I know like exactly where you are having trouble, if I try to explain now, it will basically be a rephrasing of what is there in the video. So you can just mail me. I think you have my email. I am also in that Google group. Okay, you can make a post also, or you can just mail me, and that'll be better. If it won't be helpful to you if I try to explain without knowing where you are stuck. Okay, so just mail me. Okay, explaining like where exactly you're having a problem.
Yeah, that would be great.
Yeah. So in a 3x n or 4x n chessboard, is an open knight tour possible? Yes, some cases. Not all cases, some cases.
I
And
remember in one slide, I think at the starting of some video, I actually listed all possible values of M cross N, where this closed knight tour possible in the another list in which the open knight tour is possible.
That video might come in like week 3.
Okay, yeah, and also I have given the reference where you can look at the proof for each of these cases.
Yeah. So the characterization I was talking about, no, for each pair of M and N, like that will come. That will come in the video. Not the proof. The statement will come in the video. Okay.
But we'll share the reference so where they can check the proof also.
Yes.
That paper. Yeah.
Yes. Another question about 3x6. Please mail me. Where to plot the square 3, 4 on an 8x8 chessboard? Third row, fourth column. Find the number of squares reachable from a knight starting at the square 4, 4 on an 8x8 board in exactly 2 knight moves, including the square 4, 4. So they don't understand the question, it seems. So take a 8x8 board, put a knight on 4, 4 square and make moves from the square using this knight. You make one move, you can reach some squares. Okay, so you'll have some set of squares that you've landed on. From each of these squares, you make another knight move. Now, from the starting, you've made exactly 2 knight moves, right? So the question asks you to find the total number of distinct squares that you can land on, starting from 4 by 4, 4 in exactly 2 knight moves. So when you're finding the degree of a square, right, you will make just one move. So this is just an extension of that. What about 2 moves? Okay. Okay, so let's come back to the chat. Okay, so there was a slight like small discussion about knight's tour again. When in constructing a knight's tour, we have to break the tie between two same degree squares. Is there a method or trick to make a closed knight's tour at that point by choosing a square which can lead to a closed knight's tour? Okay, so there is not a standard method or trick. Again, a heuristic inside a heuristic kind of a thing. So as we said, like the corners have less degree, right? So by following the same logic in the broader heuristic one-star rule itself, you would want, if there's a tie between a corner square and a non-corner square, it might be better to do a square in the corner. Okay, of course, this might not lead to a closed knight's tour, but it might be a tad better. That's no standard method or anything. And Yudhishthira Srinivasan. So it seems you're saying if there's a tie, both these squares will lead to a closed knight's tour. That is not really necessary. Even if you have no ties, throughout your construction, it might not lead to a knight's tour. Okay, one-star rule increases your chances of ending up with a knight's tour. Okay, it will not lead to a knight's tour. I mean, it's not necessary that it will lead to a knight's tour. Okay, just that one subtlety. If it's a tie, then it means both squares have same and smallest degree. So any of these squares will, if it shows the shortest degree and ends your game, then you might have made a mistake before that by choosing a high degree. Okay, again, I mean, this is along the same lines. One-star rule is a heuristic. That's all. It doesn't guarantee you a knight's tour. Okay. Is there any drawbacks for one-star rule while doing same thing? I mean, it just gives you a way, to increase your chances. That's all. Why is it not possible to get a knight's tour when we always go for the squares at the corners? But it's possible when we use one-star rule. Even though one-star rule tells us the squares are. Why is it not possible to get a knight's tour when we always go for the squares at the corners? But it's possible when we use one-star rule, even though one-star rule tells us the squares near the corners have smaller degrees.
But this degree depends on the number of squares already visited also, right? Not always the square closer to the corner may not have least degree, because we also consider the fact that like how many for each, I mean, like from here I can go to 4 squares, say, then one among these 4 maybe closer to the corner, but it's closer to the corner doesn't mean that will have least degree, because the degree also depends on the squares we have already visited. Maybe there may be another square which has degree 1, but this corner square could have degree 3 easily, degree 2. I mean, depends on the squares we have already visited, right? Yeah.
Yes.
That is the reason. Since one-stop keep track of these both the things actually. There's a degree when we define them. The degree depends. Also considers also whether these squares are closer to the boundary or corner, also as well as the already visited squares also taken care of, right? So maybe that is the reason one-stop works better. When you're considering only whether the square is closer to the boundary or triangle, we are missing the information about the squares that we already visited. So that is why maybe this one, maybe the method you are suggesting is having less success rate compared to odd stuff. Yeah.
Okay, so about coordinates on the chessboard, do we take the leftmost corner square as 0, 0 or 1, 1? I think we should have made this clear. The questions are written with the assumption that the leftmost corner square is 1, 1.
But in the one
Okay.
video, I have used 0, 0 as a top left corner.
Maybe that might be the reason for the doubt. Yeah.
Yeah, but I think when it is specific, when it's explicitly mentioned, I think no confusions are there. So it is okay. Yeah. If it is not mentioned explicitly, the top left corner would be is 0, 0. If it is not mentioned explicitly, then we always assume that it is 1, 1. It always labeled 1, 1. Yeah.
Can we get a knight's tour faster if we only check the degrees of the squares which are at the corners or near already visited squares? So this from the chat. Can we get a knight's tour faster if we only check the degrees of the squares which are at the corners or near already visited squares? I'm not sure.
Same with me. First thing, how this is different from one stuff rule that we have to see, so that we'll know whether it is superior. I mean, in the first place, it is superior to one stuff, right?
So what he is doing is, from a square, there might be a lot of possible onward squares, right? Instead of checking the degrees for all of these squares, he is going to check only the ones which are like, fairly near the corners or any other visited square already. Out of that, he'll choose
but
the
that
lowest.
It may lead to trouble. But it may lead to trouble, right? Because now clearly we are introducing this is deviated from one stop. But one stop we are using the one with the least degree. But as we discussed in the last question, the one near to the corner or the boundary may not be the one with the least degree.
I'm not sure about the success rate of this modified rule. Maybe I have to check. Maybe I'll let you know. I'll check.
Yeah. Also, I mean, how to check? I mean, the technicalities of comparing two methods and all, like we haven't really discussed in the course. That may be. But anyway, we'll give it a try and get back to you.
So in knight's tour, instead of visiting all squares once, what if we require the knight to visit each square exactly twice before returning? Is that possible on some boards? It's a really good question.
If visiting once is possible, then visiting twice is also possible, definitely. We can revisit, right? I mean, if it's a closed tour is there, then we can go around there to start with.
Kindly add dark mode for the web page. Yeah. Maybe the admin will take care of this. So Iyagala Ranjit, the opposite rule of one star rule. What are you asking? Do you want us to explain what the rule is, or?
So we'll think about Ritika's question and get back to that.
Yes.
Yeah, it's a very good question. Actually, we also need to think about it a bit. Yeah. Both of us are.
Who is the professor?
Okay.
Well, by professor, you just mean you are just thinking of the technical meaning, the one who professes. Then both of us are
Yeah, both of us are teaching, so both of us are professors. Yes.
right. Is there any other questions in the form? No, no more questions in the form.
No more question in the form, and maybe I think no more if no more questions. I think maybe we can stop here. But
Yeah.
broadly, one um thing we want to emphasize that explain your please explain your question very clearly. Okay. So today in forums, like we had a few questions which we couldn't really answer properly because we don't know the question or we couldn't understand the question clearly. So please spend some time in phrasing the question properly, and so that we can actually explain your doubts in a more comprehensive or more clear way. Okay, so we'll also be happy that we have addressed all the questions. Yeah.
So can you
We
try the method? Some more questions. Can you try the
yeah.
method I modified and tell if it works in the next session? Sure. Yeah,
Hmm.
for sure.
True. That will
If
do.
it's a
Hmm.
tie, yeah. If it's a tie, then it means both squares have the same smallest degree. So any of these two options will lead to a closed. I mean, we've just talked about this Yegal or Ranjit. What do you want to ask? I mean, another thing is if you are in the meeting, you can just talk. You can just unmute, like,
Yeah.
relax and just talk. It's better, no? Then it'll be a bit of a discussion. Otherwise, you have to type
Hmm.
everything. You just you can just unmute and we can just discuss. So, Yegal or Ranjit, we've already talked about this.
Okay. Okay. Good then. If no more question, we can stop the
Yeah,
session here.
yeah. So I just want to ask, like, any feedback. Again, the same question as in the previous session. Any feedback? Second week,
Comments.
I've also
Okay.
taken two videos. Comments,
Hmm.
feedback. In the Google form, searching for our school is hard. Okay, we'll tell the team. Any constructive criticism or comments, feedback, whatever you want to call it.
Okay. We ask individually how much percentage of the content they could understand easily out of 3 videos.
So one person feels it was a bit more interesting than the first week. So Veerabagu Shankar Narayanan has found already that his modified method is not as successful as one star rule. But
Hmm.
how did you find this? Like, how did you come to the conclusion that in general it's not as successful? Like, what is the success rate? Did you look at that?
Yeah. He's saying he should
So
look more
yeah,
into it.
yeah. So Ritika Kumawat, if you have a closed tour, no, and if you look at the last square, at that point you have visited every square exactly once. Since the tour is closed, you can just go back to the first square and do this tour again,
Yeah.
right? So that will give you a tour, not a tour, that will give you a trace
Say,
or something with each square visited exactly twice. Okay, so the kind of tour you are asking will exist if there's a closed tour. So
hmm.
the non obvious cases are the boats where you don't have a closed tour, but still you can have a tour like this where you can visit each square twice. That we'll think about. later and get back to you. Okay, Veerababu Shankara Narayanan, look more into it. We'll also look into it. Okay, so if there's no comments, we can end the session here.
Yeah, I look forward to meeting you next week.
So until when we'll learn only about these chess pieces? Maybe
I
two
think
more videos.
but actually they are not chess pieces. What we going to see
Yes.
next? Yeah. So yeah, maybe one or two videos, but they are not really chess pieces. We'll look at the more general giraffe, zebra, antelopes, these kind of pieces, which are generalization of knights. Okay, and yeah, soon we will switch to Peck solitaire game. Yeah, in the third week itself, I think we will start with Peck solitaire game.
Yes.
Yeah.
So Vishnu D feels that it would be nice if we had last 10 minutes discussing math trivial facts and math trivia facts, not trivial facts, right? And latest information like quiz. And Gaurav is asking, do we learn about logical problems? What we've been learning are logical problems, but I kind of get like what you're asking. It will come. It will come. So as I said, the second half of the course is a bit more mathy. So you might feel it suits your taste. I don't know. Let's see. Let's see. So Vishnu D, so you mean on Saturdays, right? The last 10 minutes of these live sessions, we can talk about other facts and information. Is that what you mean?
Yes, sir.
Right. Okay. We'll do that for sure from next week. Thank you. Since it's already overtime now.
Yeah, we can stop here and we'll meet next week. Good.
Your modified method. I like your excitement, Veerababu Shankar Narayanan. Good. Okay. And
Yeah.
we'll also look more into it and we'll look at the success rate. Okay.
Yeah.
It might work in some cases. Like we have to look at like a bit more generality, but good that you're excited. Nice. We'll also look into it and we'll certainly discuss about it. Yes.
Welcome. Okay, meet you next week, everyone. Bye, Ganesh.
Thank you.
Bye.